welcome to Hari Chemistry. So myself Dr. Hari Prasad. So today's session we will discuss conversion reactions of carboxylic acid from carboxylic acids and derivatives topics. Right. Now from these conversions reactions, students, first we will discuss methanol to acetic acid. Right. Okay. So methanol to acetic acid. Right. In this methanol to acetic acid, student, so we will approach this methanol to acetic acid in two ways, student, right? This methanol react with PbR3, then we will get CH3Br as a product. Now this CH3Br on reaction with potassium cyanide followed by the SN2 process, we will get, student, CH3Cn as a product. Now this CH3Cn on hydrolysis, it will give acetic acid as the product. This is the one preparation method, student. This is the laboratory method. And one more method also is there, student. That method is called industrial method. This method is a industrial method. This method name is called as Monsanto process. Monsanto process, and this method also called as carbonylation of alcohol or carbonylation of methanol. Carbonylation of methanol. Right. From this reaction, student, we are using a rhodium based catalyst. Rhodium based catalyst. Rhodium based catalyst, it is an expensive metal. It is a expensive metal, and we are using I2 is a co-catalyst. I2 we are using as a co-catalyst, right? Simple reaction, student. This CH3OH reaction with the CO in presence of a catalyst rhodium and I2, so gives CH3COOH. This method is a industrial method, and the name of the method is called, student, it is a Monsanto process. From this Monsanto process we can prepare methanol to acetic acid. Right. Next method, look at, student. Ethanoic acid to propanoic acid means we need increase one more carbon atom, right? Okay. Now look at, student. Ethanoic acid is nothing but, student, acetic acid only. Right. Now this ethanoic acid, student, we will treat it with the reducing agent, that is you can use lithium aluminum hydride. It is the most common reducing agent. It is the most common reducing agent for this carboxylic acid. Most common reducing agent, right? So this lithium aluminum hydride, student, it can reduce esters, aldehydes, ketones, and nitriles into their corresponding alcohols. So now it will give, student, CH3CH2OH. Right. And one more also is there, student. We can use the one more reducing agent, that is called as a hydroboration. It is a highly specific. It is a highly selective. You can use BS3 also, student, using tetrahydrofuran as a solvent, or you can use DMSO also. This is the highly selective. This is the highly selective for exclusively carboxylic acid. So this cannot reduce any ketones and aldehydes. It is exclusive. It is highly selective for acids. It is highly selective for acids. The third also you can use, student. You can use hydrogen by using a nickel, palladium or platinum catalyst by using high temperature and high pressure condition also it will give alcohol. Right. Now, okay student, you can follow any one of the method, but generally we are following the most common method is this one, lithium aluminum hydridizing a reducing agent. Now this is reacted with PCl5 and it will give student CH3, CH2, Cl. Right. Now this ethyl chloride on reaction with KCl followed by the SN2 process, then it will give CH3, CH2, Cl. Now this is on hydrolysis. So you will get student CH3, CH2, COOH. This is the propanoic acid as a product student. Right? Now this is the method of preparation of student from benzene to methyl benzoate. Right. So means here student, so benzene to ester formation. Right. Now this particular student you can take benzene is reacted with CH3Cl using AlCl3. So this is a Friedel-Crafts alkylation. Friedel-Crafts alkylation. So you will get student methyl benzene or toluene is the product. Now this methyl benzene on oxidation, so using KMNO4 under acidic conditions, or you can use hot KMNO4, then it will give student here, this is the side chain reaction student, the benzylic carbon will be converted into acid student, this is the COOH, right. Then this COOH on reaction with methyl alcohol student, ester formation takes place with the loss of water molecule, and so you will get student, this is the product is COOCH3. So this is called student methyl benzoate. Okay. So first benzene to toluene and toluene to benzoic acid and toluene to benzoic acid and benzoic acid to methyl benzoate. Right. Next student. Fourth reaction student, propanoic acid to acetic acid. So previously we did acetic acid to propanoic acid. Now we will do what? Propanoic acid to acetic acid. Right. Now look at student. So this is propanoic acid, CH3, CH2, COOH. Right. Now, this propanoic acid student, you can do the reaction with N3H followed by sulfuric acid. This name of the reaction is called student Schmidt's reaction. Schmidt's reaction. So during this process student will give CH3, CH2, NH2. Now this NH2 on reaction with NaNO2 HCl, then followed by water student. Already we know student, this is will give alcohol as the product. Now this alcohol on oxidation using Jones reagent, or you can use hot KMNO4. So it will give student CH3COOH as the product. It will give CH3COOH as the product. And one more also we can do student. One more method also we can do this process. Right. So just you can take student. This is the propanoic acid. This propanoic acid. So we will do student NaOH, right, decarboxylation process. So we will get student ethane is the product. Now this ethane on reaction with the chlorination in presence of diffused sunlight, so we will get student CH3, CH2, Cl. Now this CH3, CH2, Cl on reaction with student aqueous KOH, then it undergoes SN2 process and you will get student CH3CH2OH. Then further oxidation student, this will be converted into CH3COOH as the product. Right. So you can approach by two methods student. One method will be you can go to the propanoic acid to hydrozoic acid in presence of H2SO4 followed by the SMIDs. So means carboxylic acid is converting into amine, 1 degree amine, then followed by the NaNO2 plus HCl reaction, then convert into alcohol, then followed by the oxidation you will get the acetic acid is the product, right? Okay, so you can approach any one of these methods student, both will give the very good yield only, right? Next, nitrobenzene to benzene. So we will convert nitrobenzene to benzoic acid, right? So in this student, just you can take the nitrobenzene. So this nitrobenzene react with Sn plus HCl, or you can take Fe plus HCl. So followed by the reduction reaction student. This nitrobenzene will give aniline is the product student. This will give aniline is the product. Now this aniline on undergoing diodization, this is NaNO2 plus HCl at 0 to 5 degrees centigrade student. So you will get student BDC is the product. Benzene diazonium chloride is the product. Now this benzene diazonium chloride on reaction with phosphorus acid followed by heating, so it will give benzene is the product. Now this benzene on reaction with Friedel-Crafts alkylation, this will converted into methyl benzene. Now this methyl benzene on oxidation are using hot KMnO4. So this benzylic carbon will be converted into acid. This is converted into acid. This is the one process. Or here also you can do one more process student from here onwards. From here you can reaction with CuCN, right? Now this CuCN is converted into cyanobenzene. Now this cyanobenzene on hydrolysis, you will get acid is the product. So you can approach the reaction by these two methods student. From benzene diazonium chloride reacted with CuCN, that is the Sandmeyer reaction, then followed by the S3PO2. So you will get benzene, right? So here one more step we will reduce, right? That's it student, right? Next student, sixth one, benzene to phenyl acetic acid, right? Benzene to phenyl acetic acid. Benzene to phenyl acetic acid. Now you can take benzene student. This benzene reacted with CH3Cl. This is Friedel-Crafts alkylation. You will get toluene is the product student. Toluene is the product. Now you can do one thing student. This toluene reaction with the chlorine followed by HNO, right? So remember student, it is a side chain reaction only takes place. Side chain, that is called as a benzylic substitution takes place student. Benzylic substitution takes place. Or else student, if I use like this Cl2 followed by AlCl3 student, it will take electrophilic aromatic substitution takes place student. So that means Cl will be takes place ring substitution. Cl will be takes place ring substitution. But in presence of sunlight student, so this is a side chain substitution, right? So this will be side chain substitution. this benzylic position CH2 will be converted into CH2. So then this will be reacted with KCN, student. Then it will give CH2Cl. Then followed by hydrolysis. Then you will get, student, phenyl acetic acid. So this is the 2-phenyl acetic acid, student. So this is 1, 2. So this is the 2 position, we have a phenyl. So name we are calling as a 2-phenyl acetic acid. 2-phenyl acetic acid, right? Look at, student, 2 things you need to remember, student. So if I am using the Cl2 followed by the light condition, so side chain benzylic substitution takes place. Or if I using a Cl2 by AlCl3, student, electrophilic aromatic substitutions takes place, means ring substitution takes place. Ring substitution takes place. This point you need to remember. Next. So benzene to para-nitrobenzoic acid, meta-nitrobenzoic acid. Benzene. Now you can take benzene, student. This benzene, same scenario, student, you can take CH3Cl followed by AlCl3. Now you will get, student, toluene or methyl benzene is the product. Toluene or methyl benzene is the product. Now this methyl benzene is a electron donating group, student. So this is electron donating group. Then followed by the nitration, student, HNO3 plus H2SO4, right? So usually ortho para possible, but para is the major product. So this will be CH3NO2, right? Now this compound on oxidation, so that is a KMNO4 H plus. So it will give, student, it will give NO2 will be as it is. Now this will be converted into COOH. So now this is, student, para-nitrobenzoic acid. Now similarly we can prepare from benzene to meta-nitrobenzoic acid. Meta-nitrobenzoic acid. So from this, student, so here we will do one additional step. So you can reaction with hot KMNO4, right? So this will be converted into COOH, student. So now here we are converting methyl benzene to benzoic acid. Now, student, then you can do the reaction with the concentrated HNO3 plus H2SO4 during the nitration process, right? Now, so COOH is a electron withdrawing group, student. COOH is a very good electron withdrawing group, and so you will get the product, student. This product will be COOH, and meta substitution takes place, student. So you will get the meta-nitrobenzoic acid, right? So you can go through the para-nitrobenzoic acid as well as meta-nitrobenzoic acid by following the process, right? Next, ethyl benzene to benzoic acid. So take ethyl benzene, student. This is ethyl benzene. CH2CH3, ethyl benzene. Now this ethyl benzene to benzoic acid. This is general reaction, student. KMNO4 oxidation. KMNO4 oxidation. Any benzylic carbon will be converted into benzoic acid regardless of carbon chain, right? So this will be converted into COOH. The remaining thing will be converted into CO2 plus H2. Right. So this is the process, student. Next, bromobenzene to benzoic acid. Bromobenzene to benzoic acid. Bromobenzene to benzoic acid. Bromobenzene to benzoic acid. This is bromobenzene. Now this bromobenzene to converted into benzoic acid. Now we will do one thing, student. So we will react it with the Mg ether. So then it will form, student, MgBr, methyl magnesium bromide. Right. Now this methyl magnesium bromide, on treatment with, student, carbon dioxide, then followed by water. So then, student, you will get benzoic acid is the product. In this reaction, student, then this will be C double bond O, C double bond O, student. So this will be compound, right? This electrophile will attack here, then carbon. Generally reaction will happen. So then followed by the hydrolysis, we will get the benzoic acid is the product. Next, student, acetophenone to benzoic acid. So anything, student, you can take aldehyde, it will be converted into carboxylic acid. Ketone converted into carboxylic acid by using the strong oxidizing agent, that's it. Now look at, student, you can take acetophenone. So this is a C double bond O, CH3, right? So just use any strong oxidizing agent. Strong oxidizing agent. So usually that benzylic carbon, so will be converted into COOH. So if you take aldehyde or if you take ketone, so if benzylic carbon will be present, that will be oxidized into carboxylic acid only. Right. Next, 4-methyl acetophenone to benzene 1,4 dicarboxylic acid. 4-methyl acetophenone. 4-methyl acetophenone to benzene 1,4 dicarboxylic acid. Now this is, student, this is methyl and this is 4-methyl acetophenone to benzene 1,4 dicarboxylic acid. So using KMnO4 H plus, or you can use, student, hot KMnO4. So this, student, you will get, this will be converted into COOH and this also converted into COOH. This is called terephthalic acid. This is called, student, terephthalic acid, or we can call it as a benzene 1,4 dicarboxylic acid. So simply we are calling it as a H2BDC. H2BDC, right? Next, student. So butanol 1,2-butanoic acid. Butanol 1,2-butanoic acid, right? So butanol 1,2-butanoic acid. This is also simple reaction, student. This is CH2OH. This is 1 degree alcohol, student. So use any use Jones reagent, or you can use KMnO4, strong oxidizing agent, student. So this will be converted into CH3, CH2, CH2, COOH, butanoic acid. That 1 degree alcohol is converted into acid. 1 degree alcohol is converted into acid. Next, student. Cyclohexene to hexane 1, right? This is cyclohexene. Cyclohexene. Do one process, student. Just you can do the ozonolysis, simple process. Ozonolysis, you can do CCl4. You can do reductive ozonolysis, student, or you can do directly oxidative ozonolysis also. Oxidative ozonolysis also. Or you can do, student, KMnO4 H plus condition, right? So during the reductive ozonolysis, student, first it will be converted into aldehyde. Again we need oxidation, further oxidation. So further oxidation, student. So it requires further oxidation. This will be converted into C double bond OH. Or if you do reaction student directly oxidative ozonolysis, here also you will get the same product. You will get the same product student, that is the hexane 1,6 dioic acid, right? Next student, 3 nitrobromobenzene to 3 nitrobenzoic acid, right? Bromobenzene, right? Now look at student. So here we will do the same process. I need to convert it into benzoic acid. So I will use Mg dry ether. So this will be converted into student, this will be MgBr, magnesium bromide. So then it is followed by the carbon dioxide reaction, then followed by the water hydrolysis. So then you will get this compound is converted into COOH and this will be NO2. So this is nothing but meta-nitrobenzoic acid only, or we can call it 3-nitrobenzoic acid. Next, benzyl alcohol to phenyl ethanoic acid, benzyl alcohol student. So this is benzyl alcohol, this is CH2OH. Now this benzyl alcohol we need to convert it into phenyl ethanoic acid. That is nothing but acetic acid only student, phenyl acetic acid. Just you can do one thing student, you can use PCl5 or PCl3 or SOCl2 Darjan reaction. So then this will be converted into student CH2Cl. Am I correct? Right. Now this is followed by the KCN student, followed. Then you will get this will be CH2CN. Then this is followed by hydrolysis. This is followed by hydrolysis. CH2COOH. This is called student phenyl ethanoic acid, right? I hope these are the reaction student, conversion reactions. I think so. If you like the video student, so please subscribe and share to your friends. Thank you.